Hello and welcome to our tutorial today, and in our today's video we are going to solve the equation that you're seeing on your screen. So these are basically testing about indices, and we are going to solve it. We are going to crush it. So we first simplify by using the laws of indices. So 3 raised to the power of 2x is 3 raised to the power 2x multiplied. This dot here will signify multiplication, 3 power 2x. Then we are going to add 3 raised to power x multiplied by 3 raised to power 1, subtract 4 to get 0. What we have just done is just simplifying, make it easier to solve. So when you check from the first two arguments here, we are going to have 3 power 2 power x and 3 power x. So this one has just simplified to this one. When you check the laws of indices, it says that when the bases are the same, you are supposed to add the indices. So when you check x plus x, is basically going to give us 2x. And the same applies to the other value here. So we are going to see that we are having like terms. These 3 to the power x are appearing 3 times. So they are like terms. So we are going to make this assumption here. Let y be equal to 3 to the power of x. So wherever we are going to see 3 to the power of x, we are going to replace that with y. So we are going to have y multiplied by y added to y multiplied by 3 to the power of 1, subtract 4, and this one is going to give us 0. We're good. Now when you check that we are multiplying y and the y, we are going to obtain y squared added to 3y, because 3 to the power of 1 is 3, subtract 4, you are going to give us 0. So up to here we can see that we are now having a quadratic equation, and we have very many ways of solving a quadratic equation, one of them being the quadratic formula, others being factorization method and completing square method. So I'm going to go with the quadratic formula, which says that for us to find the value of y here, it is going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. And this equation is just derived from the basic quadratic equation. I'm going to do this in another video, so stay tuned. So we are seeing that from our equation here, the value of a is 1, the value of b is 3, we can see here. The coefficient of this term here is what we call a, and it is 1. So the coefficient of the second term here is 3, and lastly the constant is c is negative 4. So we are going to just replace them in this equation here. So y will be negative 3 plus or minus the square root. The square root of 3 squared is 9 minus 4 times 1 times negative 4 divided by 2 times 1. So realize that we have 4 times 1 times negative 4. That one will give us negative 16. And 9 minus 16 becomes now 9 plus 16, which is 25. And we know that the square root of 25 is plus or minus 5. So we'll be having negative 3 plus or minus the square root of 25 over 2. This one will be giving me negative 3 plus or minus 5 all over 2. So our first value, we are going to have negative 3 plus 5 all over 2, or negative 3 minus 5 all over 2. So negative 3 plus 5 is 2 positive divided by 2, or negative 8 divided by 2. So we'll be having 1 or -4. So that is the value of y. So we are having two values of y. So to begin with, we are going to use our value as y, because what we need in this equation is the values of x, not the values of y. Remember that. So we have found that y for the first case is 1, but we made this assumption here by letting y to be equal to 3x. Now we are going to replace the value of y with this value that we have obtained here. So that is 1 is equal to 3x, 3 to the power of x. But now, for us to solve this simple equation, for us to find the value of x, we are going to make these bases to be the same. How are we going to obtain that? We are still going to use the laws of indices. That law that says any number to the power of 0 is 1, and we are having 1 here. So we're going to use 3 to the power of 0 because we want them to be the same bases. So 3 to the power of 0 is equal to 3 to the power of x. So we can just see from just here, we are equating the indices now because the bases are the same, that x is equal to 0. X is equal to 0. And for us to prove that x is really 0, you are going to replace the x into the original equation to see if you are going to obtain 0. Now, it is 3 raised power 2. Wherever we are going to see x, we are going to replace there with 0, 0, plus 3 raised power 0 plus 1 minus 4 is equals to 0. Then we're having 3 to the power of 0 plus 3 to the power of 1 minus 4 is equals to 0. And this one is giving us 1 plus 3 minus 4 is equals to 0. And we are going to see that 0 is really equal to 0, meaning this value of x is correct. So I want you viewers to do something here. Because you have only used this value, I want you to use this other value and obtain another value of x, of which you are going to replace into that equation, and also make sure that 0 will be equal to 0. Help me know your findings in the comment section. You can subscribe if you haven't, and we keep learning this simple mathematics together. Stay tuned. Thank you for watching.